Let's do a few more examples of integration by parts. Here's a fairly unique one. Let us integrate natural log of x. Now at first glance, this may not seem like a prime candidate for integration by parts, because integration by parts concerned two functions which were being multiplied together, and then we were trying to integrate that product. But I think the key here is to acknowledge that natural log of x can be thought of as natural log of x times 1. Now at the moment I have two functions here, 1 and natural log of x. Now if only I could take the derivative of natural log of x, the natural log of x would be reduced to 1 over x, which might be a little bit easier to work with. So I will think of natural log of x as the one whose derivative has not yet been taken. And I will think of 1 as the function whose derivative has already been taken. And then I'm going to use integration by parts to move the derivative from 1 to the natural log. So if u prime is equal to 1, then u must have been equal to x, the simplest antiderivative. And if v is equal to natural log, then v prime must be equal to 1 over x. So I go back and I use the integration by parts formula, which says that this integral, if you undo chain rule here, undo product rule, and run product rule in reverse, then you will get x times v, x times v, x times natural log of x. Take away the product where the derivative has been moved off of 1, giving you an x in that position, and the derivative has been moved onto natural log, giving you a 1 over x in that position. Look at what has happened. We have arrived in the integral at x times its reciprocal. So those two x's cancel each other out completely, and we are left with u times v, x times natural log of x, take away the integral of 1. The integral of 1 is simply x. So here is our indefinite integral. Our indefinite integral of natural log is x times natural log of x minus x plus an arbitrary constant. So here we used integration by parts to find the antiderivative of natural log, which could not be found by any other means. Let's consider another example. Let's consider the product x squared times e to the x. Now I have a product here of two functions, and I think that if I took the derivative of x squared, I would get something that's a little bit simpler than what I had before. So let me call x squared v, and let me call e to the x u prime. If u prime is e to the x, then in reverse u must still be e to the x. And if v is equal to x squared, then v prime must be 2x. So if I use the integration by parts formula, then I can take u times v, x squared e to the x, and then I can subtract what I would get if I moved the derivative off of e to the x and onto x squared, 2x e to the x. Okay, well, at the moment I think that this integral in the back is still not easy to find. But nothing is stopping me from using integration by parts a second time to help me to further simplify this integral in the back here. What if I once again, in a second iteration, called e to the x u prime, and 2x, what if I called that v? because if I take the derivative of 2x, it will become simpler. So let's try that. U prime in the second loop is still e to the x, and I will call u e to the x. V in the second loop is called 2x, therefore v prime is 2. So now, if I use integration by parts to rewrite that integral in the back, instead of the integral of 2x e to the x, it will become the quantity, the new u times the new v, minus the integral of scooch the derivative from u to v. V prime times u. As a result of doing integration by parts twice, I have finally arrived upon an integral that is easy enough for me to actually calculate directly. So I can finish this problem by saying, okay, here is our x squared e to the x from the first loop. Here is the negative 2x e to the x from the second loop. And then finally, here minus minus, so plus the integral of 2e to the x, which is simply 2e to the x. Never forgetting for indefinite integrals plus c. By using integration by parts twice, once to reduce x squared to 2x, then to reduce 2x to 2, we were able to take the antiderivative of this integrand.